Today we are going to talk on Java Basics Part 1.5 Java Features, Java's platform independence, object-oriented principles, and garbage collection. So we have already covered 4 parts of the Java Basics, and for those YouTube videos are given, links are given here. So Java features are key characteristics that make Java portable, secure, and object-oriented. And major features that will be covered are platform independence, object-oriented programming, automatic garbage collection. What are those? We are going to cover in depth. So what do you mean by platform independence? Java's motto is write once and run anywhere. What does it mean? You write your Java program on Windows, compile it once, and then the same compiled file can run on Linux, macOS, or any other system. Basically, it's bytecode. So you don't rewrite anything, you don't recompile anything. How is it possible? Because Java doesn't compile your code into machine code like C or C++. Java does totally something different. It compiles your code into something called bytecode. It's a universal format that only Java virtual machine can understand, and every operating system that has its own JVM. So we are going to discuss in detail in the next slide. So the same bytecode can run everywhere. So now we are going to discuss about JVM, JRE, JDK. So what is JVM? JVM is Java Virtual Machine, and it contains execution engine, memory management, and garbage collection. Executes bytecode. So basically you can think of JVM is the building block above which JRE is residing, and then JVM plus JRE is equal to JDK. Okay, so in step 1 you write your source code into a file called test.java, right? This is human readable code that you and I can understand. In step 2 you run the Java compiler using the command javac test.java. The compiler checks your code for errors. If everything is correct, it generates a file called test.class. That class file, it contains bytecode, not your original code, not machine code, but bytecode. And in step 3 you run the program using the command java test. Notice that no class extension is required in this command, right? That launches the JVM, and JVM reads the bytecode from the test.class and converts it into machine specific instructions for your operating system and executes it. So the flow is .java file goes to javac compiler, which is JDK, which produces the .class bytecode, which goes to JVM, which talks to your operating system. So here's the critical exam point. After compilation, you only need .class file to run the program. You have to remember that. You can delete the .java file, not required, but the program will still run. And the source code is needed. The source code is needed only for compilation only. At runtime, only bytecode and JVM matter. One more thing, javac is the compiler, Java is the launcher. Just students sometimes confuse these two. Javac creates a .class file and Java runs it. So they are different. So JDK contains JRE, which contains JVM, right? So JVM is you can take it as the building block above which JRE is there, because JVM plus standard libraries plus Java command, they make JRE, right? And JRE plus javac compiler plus other development tools, they make JDK. So what are the components of JVM? JVM has 4 components: class loader, execution engine, garbage collector, and runtime data areas. So 4 main components of JVM. You don't need very deep knowledge for OCA, just you have to know them, right? So what is class loader? When you run Java app, the class loader is the first thing that kicks in. Its job is to find your .class file and load it into memory, verify that the bytecode is valid, and resolve all references, meaning it connects your class to other classes that it depends on references. Second one is the execution engine. It reads the bytecode and executes it. It can do it in 2 ways. It can interpret bytecode line by line, which is slower, or it can use something called JIT compilation, just in time. JIT identifies code that runs frequently, compiles it directly to native machine code for speed, and you don't need to know that much of JIT details for OCA. Just know that execution engine is what runs your program. And third is the garbage collector. So it runs within the JVM, monitors the heap memory, and automatically removes objects that no longer have any references that are pointing to them. No manual cleanup is required. And fourth is runtime data areas. The JVM divides memory into sections. The heap is where all your objects live. Every time you write new, the object goes into the heap. The stack is where all method calls and local variables live. For OCA, you just have to remember that objects go to the heap and local variables go to the stack. So platform independence, what really does it mean? Your .class file is is the same everywhere, like we discussed, that's platform independent. But JVM itself is different from each operating system. You have to remember that. So if you have different operating system, you have to have a JVM for that particular operating system. So you have to have a Windows JVM, you have to have a Linux JVM, you have to have a Mac OS JVM. So each one is built specifically for that OS, and as you give the same bytecode to any JVM, it will run. So who really is the portable here? The bytecode is the portable, JVM is not. The JVM is the translator that sits between your portable bytecode and the OS specific machine. On the exam, if they ask you what makes Java platform independent, the answer is bytecode plus JVM. If they ask is JVM platform independent, the answer is no. The JVM is platform dependent. This distinction is tested very frequently. So your key idea is that each OS has its own JVM implementation: Windows JVM, Linux JVM, Mac OS JVM, but all of them understand the same bytecode specification. So this is portability. Object-oriented programming overview. So Java is an object-oriented language. Everything that revolves around classes and objects here, right? So there are 4 core principles of OOP. Those are encapsulation, inheritance, polymorphism, and abstraction. So I'll give you a quick overview here, because each of one has its own dedicated chapter later in the course, right? So it will be quick overview here only. Encapsulation, wrapping your data inside a class and controlling access using private fields and public data. So you write a class, then you write all the fields there as private, but you let outsiders access those fields using a public method, right? Like getters and setters. So you can set a variable, say you have a variable called x, which is private, and but you let outsiders access that particular field using a getter or setter method, but those methods will be public. So that is how you hide the data, you expose the methods, right? That is called encapsulation. What is inheritance? One class acquiring the properties and methods of another class using extends keywords. So dog extends animal. So dog extends animal. So animal is the parent class and dog is the child class, but dog has all the capabilities of an animal. So dog gets everything animal has plus its own stuff. So this enables code reuse. So this is called inheritance. And polymorphism is basically one form, one name, but many forms. So you have various way how to interpret this. Basically, say you have one word called play. When you say play to your dog, it runs and fetches the ball. When you say play to your music system, it starts music. When you say play to your friend, you both start playing cricket, right? Same word play, but different actions depending on who is hearing it. So it's the basic expansion for polymorphism, right? So in Java there are 2 types. One is a compile time polymorphism, that is method overloading, in which case you can have in a single class you can have multiple methods, so the same name, but their signatures or parameters should be different, right? Different parameters, basically, not signatures. Different parameters should be different. We'll discuss in detail later. And then you have runtime polymorphism, that is called method overriding. So you have, say, animal class having a method called make sound, and now you say you have a variable pet of type animal, right? So you have animal class, and then you have within that animal class you have a make sound method, and now you have a variable pet of type animal. Now that variable, it points towards a dog object. When the dog class is derived from animal, and the dog class has its own make sound also, right? So dog class is derived from animal again, and dog class has its own make sound method. But when you call, say, call pet.makeSound, Java ignores the animal level and checks for the real object dog. So it runs dog's own make sound, right? So that is called runtime polymorphism, that based on the object, the particular method is called. So another one is abstraction, show only what is needed, right? Hide the rest. What does it mean? Say I give you a real life example. You have a TV remote, right? You only see the buttons, power, volume up, channel up, all these things, but you don't see and don't need to know the thousands of wires, circuits, code inside each remote or the TV, right? So that is called abstraction. Show only what is needed and hide the rest. Garbage collection. What and why? So in languages like C and C++, when you create an object in memory, you are responsible for deleting it. If you forget it, you got a memory leak. So your program slowly eats up all available memory and eventually crashes. This is a nightmare for developers. So Java solves this problem with automatic garbage collection. When you create an object using new, Java allocates memory for it on the heap. When that object is no longer being used, meaning no variable is pointing to it, Java's garbage collector automatically detects it and removes it. You don't write any delete or free command. Java will handle it. So let me let me show you a simple example. So test t is equal to new test, right? And then t, that particular variable which is pointing to that particular object of test is now assigned null. So object now becomes eligible for garbage collection. So line 1 creates a test object and t points to it, line 2 sets t to null. So now nobody is pointing to that object that was created in the first line. It's floating in memory with no reference. At this point the object becomes eligible for garbage collection. The garbage collector will eventually come and clean it, not immediately. So the keyword here is eligible, not collected, right? So the object doesn't disappear the moment its t is set to null. It becomes eligible. The garbage collector runs on its own schedule. The distinction, that's the distinction you have to remember, that it's eligible but it's not cleaned immediately, not that garbage is not collected immediately, right? Next one is let me give you 4 golden rules of garbage collection for the OCA exam. You have to memorize them. So rule number 1 is JVM decides when garbage collection runs, not you, not your code, not your operating system. The JVM looks at memory usage and decides on its own when to clean up. You have zero control over timing. Rule number 2, system.gc is a request, not a command. Yes, Java gives you a method called system.gc. You can call it for it's a request basically for garbage collection, but the JVM is free to ignore it completely. There is no guarantee. The exam loves asking what does system.gc do. The answer is it suggests garbage collection, nothing else. Rule number 3, an object becomes eligible for GC, that is garbage collection, when it has no active references. Even if one variable still points to that object, it cannot be collected. This is why the exam gives you the code with multiple references and asks you to count eligible objects. You must trace every single reference carefully. Rule number 4, eligible doesn't mean collected. An object is eligible for garbage collection and still sit in memory for a long time. The exam asks how many objects are garbage collected. That's a trick. So you can only say how many are eligible. You can never say how many are actually collected because only the JVM knows that. Let's come to question number 1, platform independence. Which statement about Java platform independence is correct? So Java source code runs directly on any operating system. Source code runs directly on any operating system, not true. Java bytecode is compiled separately for each operating system, not true. The same .class file can run on any system that has a compatible JVM, right? So option C is correct. D and E are not correct because Java JVM is platform independent. That's not true. For every OS you have to have a JVM, and Java doesn't need a JVM. That's not true. Second question is we are given a code and we have to see how many objects are eligible for garbage collection, right? So at the end, so as you see, string A new string hello and string B new string world, and then we have a string C equal to A, right? So A's object, that is hello object that was created, that object then string C is pointing to it, that hello object, right? So A is equal to null, that's fine, and B is equal to null, right? So B, but we still see though A is equal to null, that hello object is still being pointed to by string C. Though world object has nothing pointing to it. So in that case, only there are 2 objects that were created, right? Hello and world. So how many objects are eligible now? Only 1, right? So B is the answer. Hello cannot be garbage collected yet because C is pointing to it. So question number 3 on garbage collection is which statement is true? Garbage collection runs immediately when object becomes unreachable. That's not true. The programmer can force garbage. It cannot. It can just request for system.gc. That's not. JVM automatically manages memory and removes unreachable objects. That's true. So C is the answer. And D, objects are deleted when they go out of scope only. That's not true. Scope ending does not guarantee immediate garbage collection, right? Question 4, a developer writes app.java, then compiles it successfully and gets app.class. She copies only the .class file to a different computer running different operating system. What happens? So answer is C. The program will run if the other computer has a compatible JVM, right? So if it doesn't have JVM there, it will not run. So thanks for your time and let's meet in the new video.